I'm here with Mr. Kamak from Charlotte High School, and I have a few questions for you, Mr. Kamak. What should you expect when taking this class in high school?
The AP Bio class is a fast-paced biology course that's college level, so you'll be expecting to move at a fast pace.
And how do you think you can use this after high school?
The kids will have a better understanding of what a biology class in college would look like, how much studying they have to get involved with, and if they do pass an AP exam, a national AP exam, with a 3 or higher on a 5-point scale, they can get out of some college level courses.
All right, and what should students expect before taking this class?
Well, they should have a few classes. They should have a biology class with at least an A or B on it, and also a chemistry class with at least an A or B.
All right, thank you, Mr. Kamak. That's all the questions we have.
Welcome to Mr. Kamak's AP Bio class. We conducted an experiment that gives students a real-world application into using genetic concepts.
We used the Hardy-Weinberg formula and Punnett Squares to organize the data that we collected from a little over 300 students at SHS.
And we also determined the future offspring of them based on if they were going to have a widow's peak, if they were going to be colorblind, and if they could roll their tongue.
Stay tuned for the data that we collected.
What is Hardy-Weinberg? Hardy-Weinberg is known as the equation p squared plus 2pq plus q squared equals 1.
Where p squared is your homozygous dominant genotype, your 2pq is your heterozygous, and your q squared is your recessive. And the Hardy-Weinberg states that allele and genotype frequencies remain the same or constant in a population from generation to generation in the absence of other evolutionary influences. Meaning allele frequency is used to predict genotype frequency for a random mating population. But in order to find p squared and q squared, your homozygous dominant and recessive, you first have to find your p and q, which is your dominant and recessive allele, which must equal 1.
To achieve the equilibrium of these 5 conditions, these 5 conditions must be met. Population must be large. It must be isolated from others, which means no immigration, no mutations, no natural selection, which means every individual has an equal chance of survival, and random mating.
What are Punnett Squares? Punnett Squares are used to predict future generations and what they will look like. To set them up, you start with the genotypes and phenotypes of both parents, and then when you set up the Punnett Square, you place one parent on the top and one parent on the side, and then you'll make the cross, this is our example, and then you'll identify the probability of the genotypes and phenotypes of the parent's offspring. And this can apply to the one we found based off of the Streller's high school population.
This is the Punnett Squares that we did for our population here at school. If 2 homozygous recessive left-handed people have children, each child will have a 100% chance of being left-handed. If 2 heterozygous parents that are right-handed have children, their children will have a 75% chance of being right-handed and 25% chance of being left-handed. And if 2 homozygous dominant parents that are right-handed have children, their kids will be 100% right-handed. And these are the findings that we found for every single trait.
All right, so I am doing a sex-linked trait. A sex-linked trait is, there's an example of it is a color blindness. Sex-linked traits are recessive most of the time, which means it is very common for the general population to get it or carry it. You might ask, what is carrying a trait? Women carry color blindness because they have 2 X chromosomes, and the sex-linked trait is linked to the X chromosome. So if one of the chromosomes is linked to the sex-linked trait, then they're carrier. If both are, then the woman is affected. Here's an example of a genetics chart for color blindness. the deceased mother and father were both unaffected, but somehow they had 2 affected males. This is because the female was not affected, but she was a carrier. The mother was a carrier. So the mother unluckily gave the affected X chromosome to the males. So the males got it. Now, 2 of the male's offspring are also affected. So right here, he gave his Y, but he married someone who's not from the family, and she was a carrier, but she wasn't affected. So she gave her X to him, and he got affected. Now, males cannot be carriers because they only have 1 X chromosome. So in the case of a female getting it, which there isn't here because it's actually much less prone for a female to get it, there are no females in here because males are much more affected with getting it. Now you might ask, why? Because they have 1 X and girls have 2. But there is no chance for a male to be a carrier or they can only be affected or unaffected. So they either have it or they don't. Females can be a carrier. But right here, they had a female offspring who is not affected and a male who is not affected, and he can't be a carrier. But somehow they had a male affected child. That is because the female up here was a carrier, gave this female, and she was a carrier. And then furthermore, she gave her affected X to him, so he's affected. Said that. So chance of offspring, there's obviously in any type of sex-linked trait, there's a 50-50 chance of having a girl or boy XY. Now, on the other hand, there is a 75% chance of anyone being affected or carrier. Right here is an affected female. This is an affected father and a carrier female. They have a 25% chance of having an affected girl, 25% chance of having a carrier girl, 25% chance of having an affected boy and an unaffected boy. So basically, to sum it up, it's linked on the X chromosome, never the Y chromosome. Males only have 1 X, so they're either unaffected or affected, so they're more prone to having one. Females can be carriers, males cannot. And this is a representation that Mr. Kamak put on there, and they said that there's a Christmas tree somewhere in there, and I can't see it because my mom gave me color blindness. So that's it.
Handedness is considered an autosomal dominant trait.
It's also known as the Mendelian trait.
In today's population, 90% of people are right-handed and 10% of people are left-handed.
I'm right-handed, which is dominant, and she's left-handed, which is recessive.
That's it.
What's up, guys? We're going to talk about widow's peak, which is a Mendelian trait. All right, so widow's peak is just the V shape on your head if you don't have a straight hairline. Some people can get on you for that. Other people understand it. The allele is a dominant trait for widow's peak, so most people do have one, whether it's noticeable or not noticeable. Yeah, so if your mom or dad has a widow's peak, you most likely have one. It's odd to have a straight hairline, but if you're lucky enough, then good for you. Sometimes it can mean baldness, but not all the time. So if you do have widow's peak, don't worry, you're not in trouble. Click next one. All right, so pretty much you've seen this before. The big W is dominant, the little w is recessive. So if your parents have a big W, it shows over the little w. But in this corner right here, if they have 2 small W's, that means you can have a straight hairline. So famous people with a widow's peak: Hemsworth, Leo himself, and Count Dracula. Thank you.
Alright, so my trait's tongue rolling, and tongue rolling is a Mendelian trait, so you can be dominant or recessive, or heterozygous. But so our research correlated with the general statistics, so most students from our research could indeed tongue roll. Okay, so our final part of this presentation is going to be the allele frequencies of each trait, and Santino's going to kick us off with the first view.
Based upon the 300 people or so that we surveyed at Struthers High School, we got this as our data. Basically, in realistic terms, that means that 104 people cannot roll their tongues and 198 people can. Based upon the data we surveyed for handedness, and that's listed right here, 255 people are right-handed and 49 people are left-handed.
Okay, so for widow's peak, this comes out to be all of our calculations, but to put it in terms of how many people do and don't have it, so 261 people do not have widow's peak here, and 49 people do have it. Then for color blindness, these are the rest of the calculations, and to put that in terms of how many people have it here, 18 people do have color blindness, and 274 people do not have color blindness.